Okay. So I know there's a lot of words on this shared screen here. Don't worry if you can't read them, just kind of tune in so that I can give you some instructions. All of this information is on the website. And so if you go to the basic training webpage, you can find it there. Hopefully, you're all able to join us for the in-person Makerspace tour and training. Particularly if you're joining us at the hack, this would be really great because you're going to get to know the different kinds of equipment we have and how to use them. I think that there's also going to be some demonstrations with regards to our laser cutter and 3D printers and such. And so if you're able to make it, this would be great. It is scheduled for Saturday, July 20th. We're going to start promptly at 9 o'clock. And so if you can all make sure to try to be at the Makerspace by 9 o'clock. And please note that it can take you about 10 minutes to walk from the parking lot if you're driving yourself over to where we're at. Okay, and that'll run till 12:30. And I apologize, but we don't have funding for food at this event. And so bring some snacks with you. We'll have some breaks where you can nibble on some things between the tour. Okay. The physical location, we're going to be in room 1805. It's on the ground level of Bolter Hall. And the map will show this, but the entrance to the room is near the dumpsters. It's in the loading dock area between Engineering 4 and Bolter Hall. Okay. And so just keep in mind for those, this is an optional event, but it's not going to be recorded. And so we do encourage people to try to come to this event. Okay. If you're using your navigation to get to UCLA, we suggest that you use the address that's listed here. It's 420 Westwood Plaza. And actually that address is for Engineering 4, which is the building that is right off of Westwood Plaza. The reason for this, if you use the physical address for Bolter Hall, it's going to put you on the wrong side of the building, and it's going to be really hard to figure out how to navigate to where we are, okay? So if you're using the nav system, use 420 Westwood Plaza, and just know that Bolter Hall is the building behind Engineering 4, okay? There is pay by the hour spots on the rooftop of parking structure 8, and there's some very explicit instructions on how to get there, along with the campus map to do it. Okay, so rooftop of parking structure 8 is where you'd like to be if you're driving yourself and need to pay for parking. Okay, again, it's on the rooftop. There are spots that's designated pay by the hour, and then there are spots that are designated as permit. So you do have to be mindful about that. And the machines to be able to pay for your parking is located. There's like a little kiosk machine on the rooftop. And so make sure you pay for your parking before coming down. Along with that, on the website, there's walking directions to get you to the Makerspace from Westwood Plaza, which parking structure 8 is on Westwood Plaza directly across of Engineering 4, or nearish across Engineering 4. Okay. The things that you need to bring for that, we need you to bring your ID because we're going to check that as you're walking in. Okay. Because we're only allowing basic training participants. That's who I've gotten permission from the Makerspace director to have with us that day. And so it's just the basic training participants. Please bring some water. It can get warm there, and we'll be doing some standing. And so you will want to have some water on you. In addition to that, please wear closed-toed shoes. Okay, so nobody should be in slippers or sandals. And I don't think you need to wear pants, but don't wear anything baggy. And if you have long hair, make sure that you have something to tie your hair up. Okay. And the real goal of that is when we're working with the tools, we don't want you to accidentally get things caught in the tools, okay, or get injured. We want to have zero injury experiences both on Saturday as well as at hack. Okay. So that is the things that you do need to bring. Now, the university has a very strict policy on requirements to be able to work on technical projects and enter spaces with tools, and that is the lab safety fundamental concepts training, and I'm still missing some training certificates from some people. And so please go ahead and make sure that you have that done by the start of the Makerspace tour on Monday. Otherwise, or excuse me, on Saturday. Otherwise, I cannot let you in. Okay. So Anamika, Daryl, Fallon, Fernando, Joanne, Kentaro, Lahar, Ryan, Wesley, Zingwen, and Leo. I'm still missing your lab safety fundamental concepts. So this is required for the Makerspace tour. It's also required for, it was required for you to participate in basic training. And so we need you to get that in. Okay. All right. Are there any questions? So I'm looking at the chat and there's a question about food at Hack. Yes, we at Hack, we will have lunch and dinner provided for all of the participants, for the people who are coming in person. Okay. Another question about ID. It doesn't need to be your UCLA ID. It just needs to be something with a picture and your name on it. Okay. Question about you guys just ask it in the general chat because other people are curious about this too. So a question is whether or not you should wear a long sleeve or short sleeve. I would wear short sleeve. It gets warm in that space, and so you might as well be comfortable. We are going to be working with power tools that day, and so I'm a little less concerned. And even then, like long sleeve shirts that are baggy are sort of dangerous, and so the short sleeve stuff is probably better. So parking is not covered. That is the only thing that you guys need to cover. And so it can be done one of two ways, right? Like you can either pay for parking or you can have somebody drop you off at Hack. That is the only thing we don't have funding for, is transportation and parking. Okay. All really great questions. Are there any other questions before we go ahead and get started with today's activity? And I'll probably try to review them one more time at the end. So if you have any questions, go ahead and put them in the chat and I'll try to answer it. All right, Ryan, I'm going to turn it over to you. Maybe if I can ask one of the mentors to copy and paste again the sign-in sheet in case those who came a little later didn't get it.
All right, sounds good. Could I just get or just type in the chat or something, how many of you guys were able to, or I guess how many people were not able to install Git? I sent out an email earlier today. Sorry, I should have done it yesterday. But was anyone not able to get Git or hasn't done it yet? Yeah, so if you followed the installation guide that I sent in an email today, basically you just follow that guide, and I can give a couple minutes because yeah, no worries if you didn't do it. But I'll paste the link to the guide, and it really shouldn't take too long. So I'll give like a couple minutes just to get us started on it right now. And yeah, because we're gonna be using it in today's activity, and it's kind of like a team thing. So it's probably best everyone has it. But I'll give a couple minutes to follow the guide and try to install. Just because it was my fault for not letting you guys know earlier. So you don't. So when you I'm seeing a question. Do you want us to get it through Vim or VS Code? So you actually don't have to get it through anything. Like if you just install it for your operating system, like if you follow the one for Windows or Mac OS, then as long as it's on your computer, which I think you can check by running in the terminal, I think it's like git-v or something like that, or git version. Um, Default editor, I'd probably go VS Code. Just I think it's probably more commonly used. Um, yeah. Yeah, you can run this, or Jalen just sent git-s version. And it'll let you know if you have it installed, and you just do that in your terminal. So yeah, I'm just gonna wait for like a couple more, 2 more minutes. And then no worries if you don't get it fully installed because we're gonna take a break before our activity today. Actually, if you want to follow along, I'll give a couple. Yeah, I'll just give a couple more minutes. Yeah, so basically, if you want to check if you already have it installed, because actually a lot of Mac like MacBooks and things like that have it pre-installed. I'll just share my screen right now, and let's see. Yes, I'll share my screen. There you go. So can you guys all see my desktop right now? Ooh,
Yes.
okay, sweet, thank you. So yeah, if you just run git version, um, I have this git version and it works fine. As long as something pops up, then you should be good to go. Because yeah, it looks like for me, I already had it installed. Like pre-installed with Apple. Okay, yeah, and then people who installed Git, where you guys, I forget how long it takes. Where are we at? No, no rush. I just want to make sure that I'm not going too long. Okay, looks like a couple people have got it. All right, yeah. So I think we should be good to go. I'm just gonna go ahead and get started. So yeah, today we're gonna be going over Git, and it's yeah, basically just we're gonna be doing a team activity in the second half. We're gonna be using Git to kind of share code and work on a team project together. So hopefully it'll be fun. And yeah, if you haven't yet and you want to just scan the QR code or something real quick, I know we already have it in the chat. Please sign in. And yeah, okay. All right, so first of all, what is Git? Basically, Git is it's called a distributed version control system, which basically it just tracks the changes in your source code. So, if you have one version of your source code and then you make a bunch of changes to it, then you can upload those changes to your Git repository, and then the old version and the new version will both be tracked in your repository. So you can kind of switch between newer and older versions of your code, which makes it really nice because, if you find a bug or something like that, and you just like, you need to go back to a previous version that didn't have the bug, Git makes it really easy to do so. And then Git, which is really nice, it also allows for remote repositories, which basically means that it's hosted online. So the default Git repositories, I know this is probably a foreign language to a lot of you, are basically just only on your computer. And remote repositories allow you kind of share your code and operate on a Git repository with other users. Yeah. So yeah, a repository, Git repository is pretty much just a folder that stores your project within it. And this folder also stores all the previous versions of your project, any versions of your product that you've had, which makes it really nice because, yeah, like I was saying before, if you have a bug, if you want to just go back to an older version, you can easily do so, and you can switch back and forth, and your old code will be back on your computer in an instant. So it's really nice. Yeah, a local repository is mainly for if you're developing a project on your own. So it keeps track of your changes, but doesn't allow for other people to see those changes. And it still is definitely good practice to use Git, even if you're just working on a project solo. So that's kind of what a local repository is for. Like I said, a remote repository allows you to share code with others. So a bunch of different people can all make new files or make changes to files and then upload those changes to the same repository. So instead of it just being all 10 versions of your code, it's just going to be your changes to the code, but then also everybody else's changes to the code. So it makes for a much, much faster and more efficient software development process. And not all companies will use GitHub. Like I think Google, I want to say, or Facebook, I forget, or if not both of them, they use their own version control system, which is suited to their liking. But GitHub is just a really, or sorry, they don't always use Git. They use their own version control. But GitHub's just a really, really popular one. And the nice thing also about remote repositories is that it allows you to kind of share your code. So that's a big thing with recruiters or something like that, because it's great if you can, you know, say, oh, yes, I did this project on your resume, but actually seeing the code and the evidence that you were the one that's uploading this code, it's definitely good for people to see that, oh, he's actually working, or he or she are actually working on these projects. So yeah, it's definitely a really good tool to get used to. So now I'm going to kind of go through how a Git repository works, kind of really just the basics of it. I'm not going to get too much into it. So pretty much we have three areas of a Git repository. So, or kind of three stages of how you'll use Git in your development. So you have your working directory. Now the working directory is just the files that are on my computer. Like if let's say I have a project folder, right? Like how we went in React and I told you to make a project folder. And then inside of that project folder is your React code. So pretty much you'd have a Git repository that's associated with that code. That's what normal practice is. So the working directory is just the code that you have in your on your computer. And we'll get into this with more detail later. So yeah, so like I was saying, this is the actual code in your files. So when you're writing to a file in VS Code, for example, or another text editor that you like, these are the changes that you're making when, I just type a bunch of stuff and press save. That is making changes to your working directory. So that's just the terminology that we're going to use. Yeah. Next up is the staging area, or more formally known as the index. So this is pretty much where you're placing your files that are changed before they are uploaded to your repository. So pretty much, let's say I have a working repository or a working directory and it has one file in it. And then that file is on version 1.0, let's say, in our repository. So we've already uploaded our current file to the repository and it's known as version 1.0. Then we find a bug, so we want to make some changes. So what I'm going to do is make a change to my working directory. And then once I've made those changes, I'm going to add those changes to the index. The index is basically just a preview for changes that you're going to make to your repository. So you're going to add them to the index first. And the way that you do that by running a command is you do git add and then a file name or a folder name. And I know I'm explaining this all in words, but I'll go through actual examples so we can kind of see it in action. But really, this is just to get the concept in your head. So yeah, basically when you run git add, it takes the changes that you made in your working directory and it adds them to the staging area or the index. And then in order to get to the repository, you're going to be running a commit. So pretty much the repository is just the folder that keeps track of all the versions of your project. So, you make your initial project and then you make some changes to it and you commit those changes. And then now it holds two versions of your project and you can kind of switch in between those when you want. Yeah. So you interact with this repository. There's a couple ways you can do it. First of all, by checking out. So it's called a git checkout. And you can do git checkout to a commit name, because basically each commit that you do is going to have a unique ID with it. So you can just git checkout to that commit, and then that will basically bring whatever the commit was in my repository that I'm going to. So if I'm going to version 2 of my code, that will bring version 2, even if it's a really previous version, back into my working directory, and I can work on it from there. So that's what checkout is used for. Commit is the other way around. So it's basically saying, I have made these changes from in my working directory. I've added them to the staging area or the index. And then it basically running a git commit, and then we just use -m, and then in the parentheses our commit message. That basically just takes our current version that is in the index, I guess I could say, and then it just commits it to the repository. So then after we've committed, that's going to be a whole nother version that we'll see. And you can kind of think of this almost like a directed graph. And I'll have visuals up later. But yeah, I'm just going to keep going because I have a feeling I'll answer a lot of your questions as we go along, but I'll stop and have time for questions. All right, so I'm going to go over an example right now. So I'm just going to start by making a file called foo.py. So I'm just going to go on my desktop, and then I'll just make a folder called test. Okay, so pretty much all I've done is in this bottom right corner, I have a new folder on my desktop called test. And then I have a new file called py. So, or foo.py. So I just want to print in this file foo. Now, and then okay. So if I run this file, it just prints out foo. So we'll call this version 1 of my code. So I'm going to see right here, if I want to get this into a Git repository, first of all, I have to initialize. So you do that by running git init, and this just created an empty Git repository inside of my current folder right now. Yeah, so I just created a empty folder, and you guys are welcome to follow along too. I'll kind of slow down if you guys want to try to follow along. But yeah, so all I've done so far is made a file named foo.py, and then I've initialized a repository inside of my project. Now let's say I want to commit this version to my repository. Does anyone know what I do first? Could I get some answers in the chat if you have any guesses? You don't have to say the actual command if you just wanted to, say it in words. I haven't gone over this, but just check in. Or if you want to speak up, that would also be great. Here's some explanations. Okay, yes, so I'm seeing some good things right here. Vincent said git add, and this is 100% correct. And then Lucia also said the index stage. So that's also doing the same thing. So I need to run a git add, which contains foo.py in order to get my changes into the index stage. Like if we go back right here, we need to run a git add, like I was saying here, which goes from our working directory into the staging directory or the index. Okay, so I'm just going to run git add foo.py. Now, there's a couple ways that I could do this. I could do git add foo.py, which just adds the one file named foo.py, or what's I commonly do is I just run git add dot. And does anyone remember what the what dot means in terms of navigating our file system, what this means? So if we're in the directory test, what does dot refer to? Okay, good. I'm seeing some good answers in here. Yes, so that it pretty much dot just means the current folder that we are in or the current directory that we are in. So if I'm git adding dot, that means I'm just adding my entire test directory, whatever is located inside of my test folder, into the index. So when I run git add dot, then it shows us, okay, this is what, or then it just adds everything that's in here. So if I had more files, then they'd also get added if they have changes to them. And yeah, when you add something, like if I ran git add dot and I have 5 files, but I only changed one of them, only the one file you changed will get added to the index. It just only really keeps track of the changes. So I'm just running git add dot. And then a way that you can check that it's added is by running git status. So this basically just tells you a couple things. So we're saying we're on branch main, which we'll get into later. It's saying we have had no commits yet, which is perfect. We haven't committed anything. And the changes to be committed. This is pretty much just letting us know that we have changes that are tracked. And the fact that it's in green means that we have added it to the index. And it's kind of just one of those things where you'll use it a bunch and you get more used to it. But yeah, so right now we are in the index stage. Now, if we want to get into the repository, what would I need to run? Perfect. So when I commit this, basically there will just be a version of my code inside of my repository that has a specific name, a specific commit hash is what it's called. And it's just going to be a long string of numbers and letters that it's not named or anything like that, but you can go back to it if you want. So I'm going to run git. Oops. And then the -m pretty much just means we're adding a message because with every commit, it requires a message. So I'll just say first commit, which this is not a good thing to do, by the way. On your commit messages, you always want to have something noting what you did. So I guess I probably should have said added file foo.py, which prints foo. So this would be a better commit message. You want to have some summary of the changes that you made, especially when you're in a big team. Okay, so I have committed this. So now if I check my status, there's nothing to commit. We haven't made any changes. And yeah. So next up, I want to do something a little different. So I want to add another line to my file and then print bar. So I want to add this and I want to print bar. Let's just make sure it works. Okay, cool. We printed foo and then printed bar. I want to get this to my repository. Remind me what the first step is in the chat. Perfect. Everyone's getting it. Yeah, we're gonna git add, and I just out of habit just always do git add dot. You could also do git add foo.py. In this situation, they both work. And then I'm gonna do my commit message. So now we are going from the index area to the repository. So now we're gonna have another version of our repository. And then I'll just do. Okay, cool. So now we check our status. Good, nothing's here. One other cool thing that we can do is check the log. So if I go git log, this basically just gives us a previous or a past history of our commits. So we have made 2 commits. So this just lines up perfectly. We see our one that I've highlighted, and it has this huge commit hash, which is supposed to be unique. So that's why it's so long and unreadable. And we see our commit message right here. which was our first one. And then our most previous one will have the head. It will have the head tag, I guess you could say. The head tag basically just means our most previous commit. It's not too important right now, but just want to let you guys know this will tell you what your most previous commit is. So let's say I'm not happy and I wanted to go back to my old version. There was a way that we could do this. Does anyone remember how? If I wanted to go back to an old version of my code. Okay, yeah, perfect. So I'm seeing a lot of checkouts, and this is exactly right. So just think of git checkout as like you're literally going to check it out. Like that, I mean, that's why it's the name, but like I want to go check out my old version. So what you do is you can say git log, like I just said, and then you can go see what the commit hash is, and then we can just say git checkout, and then we can paste this commit hash. Now, if you guys, so I'm going to press enter. If you guys pay attention, my current working directory will go back to our old version. So if I go git checkout and then I'm here, then I go like this. Now we see this has changed back to our old version. So it's really nice in terms of being able to see different changes. And yeah, so if I want to go back, let's see. Then we're going to run git switch minus, it looks like. Okay, yeah. And that goes back to our old one. So let's see, git checkout, and then we'll do this one. This is our first version. It's running, it's look like you can go git switch minus, and then that will bring you back to your current version, if that makes sense. So yeah, you can switch back and forth between newer and older versions. Okay, so now, so we've made our second commit, and now I want to run, I want to remove the file foo and then add a file called bar. So I can go ahead and do this. So I say, I don't like this file anymore. I'm going to delete it. And then I want to add another one called bar.py. And then in this one, I'm going to do something different. By doing just bar. I know, crazy stuff. All right, run it to make sure it looks fine. Oops. Cool, this works fine. So now we can go ahead and add our changes. And if you see the U, it just basically like this is just a extension that VS Code has. And or I don't even know if it's an extension. I think it might be just with VS Code. Basically, it's just highlighting the U just means this is a new file, like an untracked file, like it hasn't been tracked yet. So if we do git add dot, it's adding our file bar.py, and then we can just say made new file called bar. And now we've committed, and then we look in our log, and then we can now see we had our first commit down here, which is added file foo.py, which prints foo. And then we have our second commit, which added the line bar. But then now we just said, you know what, I want a new file called bar. So I just said made new file called bar, and we can still go back to these versions. And if I do like this, now we're back to having our old file name. We see foo.py is back. Does anyone have any questions about how kind of the cycle of adds and commits and checkouts works? Okay, cool. All right. So yeah, so this would kind of be just a graph of how it goes. Okay, so I have a question. When we deleted foo.py, does git delete it too? No, so actually, so we can see right now I'm in my most current version. So I have my file bar.py, and then I'm saying, I it's a completely different file. You saw me delete it. But let's say I actually liked foo.py better and the contents of foo.py better. So then if I go to my git log, I can go back to my most previous commit, and which is this one, because I just ran git log right now. Git log right here. And then our head is at D9 ED whatever. And so that's where we're looking. And pretty much I'm just gonna run a git checkout to my most previous one, which is this FD whatever. And now we see we actually have the file back, which is called foo.py. So this is actually pretty cool because if you mistakenly delete a file or something like that, and you want to just be able to go back, I don't know exactly what the situation is. You can go back to an old version which has the file if you wanted. So this is back to the file foo.py. And yeah, so if I open it up again, because it was still opening bar.py. Good. And I'm gonna do my git switch minus. Okay, cool. And believe me, it oh wait. Okay, I think it might be because I had the editor still open. I don't know. I'm not sure. This shouldn't be here though. Okay. All right. Sorry, I'm just looking through. Okay, so what is the point of the index? Could it not be from working directory to repository? Now, I actually had this question a while ago, and basically it's just for a way to preview your changes, because if you wanted to, you could commit, like let's say you made changes to 4 files or something like that, and you only wanted to commit 2 of them. I guess you can just add 2 to the index and then run commit. I think this is just a styling thing they did. I don't really have a perfect answer to it, to be honest. Um, but yeah, it's just how it works. Okay, yeah. So I have another question. Could you go over how to write notes on your changes? Okay, yeah. So pretty much, what Git requires you to do is have a commit message. So the way that we do so all in one line, which just makes it really easy, is just by running the git commit -m and then have your message in parentheses. So let's say I add another line. Um, I don't know, x equals true, print x. Okay, cool. So we added this stuff, right? I just want to add my current files, and then commit them. The way that we add the message to our commit is just by doing git commit and then -m, and then in the parentheses you have whatever your note is. So we say added boolean x and printed its value. So yeah, that's how you add the message, and a message that's required with each one. And you really want to try to make it you really want to try to make it as concise, but also as informational as possible. I'd say it's the best way. Okay, yeah, so I have another thing, just asking, when we add and commit a file, can you explain where it goes? Does Git store it? So yeah, actually, if you, there's a bunch of stuff that Git kind of stores behind the scenes, like a bunch of information. So if I run ls, right, and I'm inside of test, that's just listing all the folders and files inside of my current directory. It doesn't show anything. But then if you run ls-a, it's just saying I want to see all the files, even hidden files and folders. So basically a hidden file or folder is one that starts with a dot. So if we done ls-a, we'll see we have dot, which is just our current and parent self. We also have this dot git. So this is where the repository is. Now we look in the dot git and there's a bunch of other stuff. I'm not going to go too into detail, but this is basically how they store it because it's just kind of out of the scope. If you're computer science and you have to take CS35L, believe me, you go very in depth into this. At least with Professor Eggert, which honestly was great because he's very smart, but yeah, you go very in depth into the Git internals. But I'm not going to go too far into it now, just because it gets kind of wild. Okay, and then I have another question. So do all your versions of code automatically go to your GitHub page? Okay, so they don't automatically go to your GitHub page. We will be going through how you interact with your remote repository, which is the GitHub repository in a bit. But they don't automatically go. So you have to kind of do this manually. When we want to save anything, wait, do you always have to run the command commit? Just running code versus code does not do anything on code vs code does not do anything on Git, right? Yeah, so basically if you want to save something just on your actual computer, all you have to do is just press save, right? But then if you want to actually put it into your repository and have it tracked by Git, then you have to run git commit. If that answers your question. Okay. Any other questions before we move on? And just another thing, you really want to make as many commits, or not as many commits as possible, but you want to make commits frequently. Because if you just think about it this way, let's say I'm developing some app and I'm working 8 hours straight on it and I'm making a bunch of changes, right? You really want to track as many changes as possible because if you mess up somewhere, you want to be able to go back to a very previous version. Like let's say I only committed like once a week or something like that, and then I messed up my code this week. That means that I'd have to go back an entire week to see my previous version, if that makes sense. So, or like all my previous version would have be a week ago. And sometimes it's kind of too far. You've done too much work. You made too many changes. So it's good to commit frequently. Like there's actually a GitHub or a GitHub repository, I believe, and you can see like the creators of Git working on it, and they're making like hundreds of commits a day. So it's definitely a good thing to do. Is just to commit a lot. I just got another question. Is there any tool for auto commit or something? So of my knowledge, there isn't a tool for auto committing. However, I know VS Code, I think it's yeah, source if we go to source control, VS Code has its own like Git interface. So you can, you can connect to a GitHub and do it this way. I don't really, but I know you can, but I haven't done much, so I can't really talk about it that much. But yeah, this one's like a little more visually pleasing, I guess you could say. Okay, yeah, so here are just some commonly used Git commands. We have git init, which just creates an empty repository in the current folder that you're in, or like the current directory that you're in. So in this previous case, I was in the test folder, so it just created a repository in the test folder. The git add, which is the file name or folder name, just adds it to the index. Commit, it publishes a commit message or a commit with a commit message, and then git checkout, that just goes to a commit hash or a branch name. And we'll be getting into branches, I think, up next. But yeah, so you can either go to a commit hash or a branch name. And then if you use git checkout -b and then you make a branch name or you say a branch name, then that will create a new branch, which I'll get into because when I was learning branches, I was so confused. So I'm gonna try to do the best I can to get like a conceptual knowledge out there. I would say a really good thing to do if you really want to learn Git and how to use it, is just play around with it. Like just make stupid files and changes that you don't care about and just play around with it, do a bunch of different commands because I have tripped myself up a lot when I'm just doing homework or something like that. And I'm like, yeah, I want to be super professional and I want to be using Git and track all my changes. And I've tripped myself up because I'm trying to do too much or I don't fully understand it. So I'd say it's definitely good to play around with and kind of like mess up a couple times because that's how you're going to learn and find out what things really do. Okay, yeah. So branches can be a very confusing topic because the way that I was thinking about it, right? If we go back to this, I was thinking about like this is a branch, like this whole line is a branch right here. And then I could branch another one off this way if you're following my mouse. I was thinking about it like that when it's not exactly that. It kind of does branch off, but it's not the whole string of commits, if that makes sense. So pretty much they're just a pointer to a certain commit hash. And the pointer is moved from commit to commit while you're making commits on that branch. So if we go back, and I'm just in my test category, right? The default branch that comes with a Git repository is called the main branch. So if I have uh my Git repository, if I do Git branch, we can see it just says main right here with a little star. It's highlighted in green. If I wanted to make another branch, I'm just gonna say Ryan. Then I do a Git checkout. Oh, sorry, I'm already on Ryan. Yeah, but if I do a Git branch, then this shows me now I'm on Ryan and it's highlighted in green. We also have another branch called Ryan. I'm gonna go back to the Git log just to kind of explain it a little bit. When you create another branch, it branches off from wherever you are currently. So we see our most previous commit, which is just added the Boolean X and printed its value. Now I have the head is pointing to Ryan. So that means I'm on Ryan. And then main. It says Ryan comma main. So that means that both Ryan and main are located at this branch. So they're both pretty much just Ryan and main are both located at this commit. They're both pointing at this commit. It's just saying like if you check out to Ryan, then it means that you're going to be right at this commit. However, if I was to make another change, let's say print hello, if I was to print hello, right? I need to add my changes and then commit. Now, if we do our git log again, our most previous commit is added hello. However, main is now left behind because we weren't on main when we did this commit. So now Ryan moved with it. So the branch is pretty much a pointer that just kind of moves with the new commits while you're on it. And I have a graphic for this that'll make more sense. But yeah, that's pretty much the gist of it. Okay. Okay, yeah, so I have a little animation here, right? So we have our file called foo.py, let's say. And we've just made it empty repository. So we are just on the main branch, and this main branch is located at this gray circle. We'll just call the gray circle a commit, or like each gray circle is a commit. So I've done my first commit. My main branch is on my first commit. And then pretty much, oh, sorry, I got a question in the chat. Okay, yeah. So pretty much, I got a question asking, does the command init do the same thing as combining the commands add and commit as both commands lead to the repository? So I'm glad you asked this question, because it's honestly a pretty common misconception. Basically, the command init, all it's doing, so you only do it one time in your repository. all it's doing is just saying, I want to create a repository. So if I didn't have the command in it, then Git would not be tracking. I would have nothing. I would have no .git folder, but it just makes the repository. Initially, it's empty. So that's why you have to make adds and commits in order to populate it with the versions of your code. That makes sense. So like, first of all, I run my command git init, and then git init is that my repository is completely empty, right? Then I commit one time. Now my repository contains my first commit. I commit another time. Now it contains both of my commits. So all git init is doing is just have it like it's just making that initial repository inside of your product folder. Okay. Hopefully that answered your question. Okay, so now with branches, assume we're at a point here where the gray circle is just a commit, right? And then the names, like for example, main is just the name of a branch, right? So I've made a file called foo.py. I've initialized my repository with git init, and I've added and committed my first commit. So now because it's the default, my branch main is located at my first commit, right? So now I'm going to make a new branch. So I say git checkout -b test. So test is also located at this commit right now, just because I just made the branch while we're still on this commit, right? Or while we're still on the branch main. That's what it branches off of. Okay, so then second of all, I make a change to foo.py. So then I'm guessing you guys know what's going to happen next. We're going to do a git add, which adds the entire, or git add dot. So it adds our whole current directory, which in this case just adds foo.py to the index. And then we're going to commit it. Now, right as we committed this, we see the git commit -m added print statement to debug. That's just a random message. Now we see this new commit has popped up, right? So its parent is this one, the left circle, but now this new commit has popped up. And so this gray circle is the commit. But since we were on the branch test, we checked out to test. That means that test is going to move with the commits that we could do. So since we did checkout test, and then we did a commit, test is going to move with that specific commit because we're on that branch. Now we git checkout to main. Let's just say I made another change. Sorry, I didn't add it here. Let's just say I made another change to foo.py from my original version. Maybe there was a bug in the one that I did on test. So I'm going to add dot, which adds our entire current directory. And then next up, I'm going to ask you guys, what do we think happens when I run commit? Okay, so I'm seeing a couple things. One is new branch. Another one is test points to a diff version of itself. Basically, main is going to move with the new commit. So we are at this left node. So we checked out to main. So that means that we are at main right now. Like our current directory is at main. And main points to this gray circle, which is the first commit. So we're going to commit again. And then in this case, we wanted to add a README. So now main is going to be pointing at this new commit, but it's going to be going off in a different direction. And so now one of them is main points to a new branch. So this is not exactly true because main itself is the branch. It main, like a branch, it literally just think about it. It points to a certain commit, and that's all it does. So it's not the whole branch itself. Like it's not like these two connected. It's not like this line's a branch. It's not like these two are a branch. It's just main. The name main is a branch itself. Okay. So is anyone confused on kind of what a branch is? Because I know it can be really confusing. Like, please don't be afraid to speak up because I was like so confused when.
So what you're saying is like you basically have like a main like a repository, and then inside of it there's different branches that all point to main.
Okay, no. So pretty much, uh, I've made a repository. Okay, so that repository, just think about it as a folder. It doesn't like it doesn't have it's not a main repository. It's not anything like that. It's just a folder. Okay, within that folder, there is a bunch of different versions of my code. Going from old to new, and they all have a certain commit with them. Okay, so my first commit is just gonna have. Okay, sorry, I'll back up. So yeah, there's a bunch of different versions of my code inside of this big repository, right? But initially when we start and I ran git init, I had to make a first commit, which is basically just saying I want to place this first version of my code in the repository. That's what committing does. So if I want to commit something, it's just I take this version of my code and I put it in the repository. Now, by default, the branch that you start on is called main. Okay. All that a branch is a pointer to one of these commits, is a pointer to one of the versions of your code. That's the best way to think about it. It's not like a complete bloodline, like when I'm saying a graph, it's not like this long path. That's not a branch. It's literally just the name of a pointer that points to a commit. Does this make sense?
Yeah, it's just pointing to like a part of your like program, right? And then each so like for example, you had like foo.py,
Mhm.
and then once you have bar.py just points to that other branch, right? It just keeps like it. So like for example, like there's like a pointer to test, and then there's another, and then if you create like a new like if you have like a new file and then you push it to main,
Mhm.
then you'll get like another pointer to that file inside main.
Okay, so no, so not exactly right. So I don't want us to think about it inside main. Like main is like there's nothing inside main. Okay, so I think I have this big repository. Big repository is just a folder. I have a bunch of commits in it. Do you understand what commits are? It's okay if you don't. Like I know we have to go fast, or like you don't have a lot of time.
A commit is basically like you're pushing a new version of your code.
Exactly. Yep. So it's just like I have this one like my first commit is just the first version of my code that I've given to the repository, and then I have another commit that is just I've updated that code. So now this is the next version of my code, right? All that a branch is. So main is a branch, test is a branch. All that does is just point to a commit. Okay. So if I do git checkout main, then it's just going to be main is just pointing to one of the commits. So like don't think of the gray circles as having like don't think of the gray circles as this is main, this is test. The gray circle is a commit. Okay. So then by default, when you make your repository, you start on the main branch. So your first commit is just going to have a pointer, which is the same thing as a branch, pointing at it called main. Now, when I make a new commit, while I'm still on the main branch, when I make a new commit, then that branch called main is going to move with to the next commit, if that makes sense. So like, okay, I'll do it with this example. So we start off with main, we're on our first commit. Then I say git checkout -b test, which just makes a new branch branching off from where I'm at. So now there's also another pointer or branch pointing at this first commit, which is called test. I make my changes, I commit them. Now there's another commit that branches off from our first one. That commit just has a pointer at it, which is called test. Test is the pointer, test is the branch. Does this make sense? Still confusing? Sorry, I don't know if I can, or I'm trying to think of what else I can explain. It's a really confusing topic.
I had a question, Ryan. So with just doing the checkout, we cannot go back to the file. So why we need like the pointer to point to that file too?
Sorry, what do you mean if you do a checkout, you can't go back to
the check? If we just do the checkout, we can just have access to any file, like basically like the log you said, and we can see all the basically commits that we have, and we can just go back to the one that we want. So in that case, why we need like to have any pointer to point out to a main or whatever? Like what is how are we gonna use that pointer?
Okay, so basically how it works, right, is if let's say I have this main branch, which I just want to be like a sorry, I'm going to go back. So right now, since we haven't made any new branches or anything like that, we're just on the main branch. So we have our commit 1, so the main branch started at commit 1, and then when we did commit 2, the main branch moved to commit 2, and then we did another commit, and the main branch moved with it to the commit 3. The main branch is just a pointer to a commit, right? Let's say there's another person doing some work and they want to work on it at the same time as me, but we don't want to both make changes to the same code because that can be really hectic. You can make your own branch or something like that and then start working on it that way.
Oh, okay.
Yeah. So it's like you don't necessarily need it. However, it's just a good way to kind of separate the people that are working on the code, I guess, or like different things you're working on in the code.
Yeah, I got it. Makes sense.
Okay.
Thank you.
Yep. Okay, and it's saying, does main not hold the different versions of our code? Is main there to point to those versions? Does test have the actual version of our code? Okay, so pretty much just main and test main and test do not hold anything, if that makes sense. They just point to a certain commit. So oops. I have, in this example, commit 1, and imagine that main is on commit 1. Like imagine my mouse is just where main is. Main is just pointing to this commit. It's not holding anything really. It's just pointing to this exact commit. So then when I make a new commit while I'm still on the main branch, main will move to that next commit. But in the scenario where I have main and test on commit 1, like we do in this example, right? Only the branch that I'm on is going to move with my new commits. So because I'm on the branch test, even though they're both pointing to the same commit, when I commit, test will also move with that commit. So think of it like I've made a commit and then test has followed along with that commit because we ourselves, the developer, is on the branch test. So the the branches are not holding anything. They're just pointing at commits that are in our repository. I think that's the best way to think about it. Okay, and I have another question saying, how do you merge them if two people are working on two different versions of code? So basically how it goes in like actual team development usually is you don't touch, or at least what I've done. I'm not a professional or anything, but you don't touch the main branch, and then you'll have like a project. You'll have someone overseeing the merges onto the main branch. So if you want the main branch, I don't know if you guys can see my cursor, to kind of just be this like steady like line, and then you'll just merge other people's code onto it. So you really want to keep it kind of modular and separate what you're working on. Like you probably shouldn't have too many people working on the same file, because then it can get really hectic. We're not going to get into all of that because it gets so hectic. But imagine I have this test, right? I've made a bunch of changes to test. If these tests go right and I say, okay, I want my main to now have like what test has, then I can merge test onto main. It makes sense. And so a bunch of different people can do this to add their code to this one main version, if that answers your question. Okay, cool. And yeah, so we can walk through this example again. I really am trying my best. I know it's really confusing. Don't feel bad if you're not understanding it. Like, don't be afraid. Like I was stuck on this for so long. Okay, so once again we started. And keep in mind, don't think of these circles as branches. Don't think of the lines that you see as branches. All right. Just the text, which just test and main, they're the only branches. Okay. So main is a branch. Main is pointing at our commit, which is this big gray circle, right? So they're not like, this is not the main branch. Like the circle is not the main branch. I want you to look this way. So I'm on the main branch. I just made my first commit. So main follows along with that commit. So now main is pointing at this big gray circle. Okay. Now I want to try a new branch. So I do git checkout -b test, which is just saying I want to make a new branch to branch off of where we're at, and then switch into that branch, check out that branch. So because I just made it, these two branches, test and main, are both pointing at the same commit, the same gray circle. However, if I was to make changes now, I'm only making changes on the test branch. So when I make those changes, if I make a commit, test is the only thing that's going to follow it. Our repository still holds every single piece of data. Like it still holds all these commits, but in terms of branches, test is the only one that followed along with this commit. Main still stayed back at the previous commit because we weren't on that branch when we did this commit. So test followed along with this commit that we just did. But then let's just say I wanted to go back to main. We can do git checkout main. So now we are working on the main branch. Main now, if we did a commit on main, it would go a completely separate way from test. So it'd still be another commit, but it'd be going almost in like a different direction, right? So we add the change that we made and we commit it. So both of these commits, the one that had test on it and the one that has main on it, they both are children of this previous commit, this gray circle. But since they are both different branches, it means that the commits just went off in separate ways. All right. Is there any confusion with this?
So what you're saying is, like for example, in the test, the statement added print statement to debug will only be in test, like it won't show up in main.
Yes, exactly. So pretty much because they both stemmed from this one, right? So you know what, I should just do an example to show. Okay. And then I just got another question. Sorry, I'm just gonna go over it real quick. What branch will the first commit be? As long as you don't do anything, it will be main. So I'm at least I'm pretty sure. So I'm gonna, honestly, I'm just gonna make a new repository and start from scratch just to show you guys what it looked like. So let's make test one, let's say. Okay. And then I'll make my file foo.py. And then I'm in my terminal. Okay. So I have def main. Okay. Okay, yeah, so this file works. So I have not made a new repository yet. So I have to run git init, right? Now, if we run git branch, there's nothing because we haven't made any commits yet. So the first commit is just always going to be attached with the main branch, right? So I'm gonna commit. So I run git add. Yep. Okay. So now if I run git branch, we see we're on the main branch right now. So we are at this point. So we've just made a commit and our main branch is just pointing at this commit right here. Okay. Now, let's say that we're working in a big team, right? Imagine if we were all working on the main branch and then we all wanted to commit our versions to it. Okay. So like let's say one person's working on, I don't know, if two people are working on the same file, right? And I want to add a bunch of gibberish like x equals true, but then someone else is also working on the same file and they add x equals false, and then we both commit to main, then it's not gonna work. So what you'd rather do is say, I'm gonna create a new branch. So I'm just gonna check. I'm on main right now. So I'm gonna make a new branch by doing git checkout -b, in which I go to the new branch test, let's say. Okay. So now we run git branch. We are on the branch test. All right. So pretty much, we are going to run, let's say x equals true. All right, and then we do git add, git commit. Okay. So now, if I run my git log, we see that test followed along with this most previous commit, right? But main stayed back. So if we did git checkout main, now this goes back to our old code. All right. So this is just like this just all that test and main are just a pointer saying I'm attached to this line of code. So then now if we're in main, right? And I want to make another change that says x equals false, right? Then I'd add it. Oh my God. Okay. So now I run git branch. I'm still on main and I run git log. Now we see that main is here, but main has absolutely no idea about test. because all it knows of is its parent, right? So its parent is this B7 whatever. So that's exactly what's happening here. So main only knows of its parents and its parents, whatever. So main has absolutely no idea about test. It's just they're two completely separate lines of which your project have gone on. Later, you could merge them, together, but there could be conflicts with that. So we're not even going to really get that much into all of that, or at all, actually, because I just think it'll be too much. But yeah, later if you wanted, you could merge these or something like that. But then let's say we want to go now back to test, and then we ran a git log. Test also has no idea of main, but they both have a previous commit. Their parent commit is both B7, BE3, or whatever. If I go back and look at this one, main's parent is also B7, BE3. So that's what I'm just drawing here, right? They're just attached to a commit. So this one's attached to right now 6C, 5AB, whatever. But then if we do another change, and then we do another log, now test used to be on this 6CE, 5, whatever, but now it followed the path along, it followed along that path. So it followed to the next commit, which is 6291, whatever. So if we went to this, it would be like as if test moved to another commit, and it has now two parent commits, or like a parent commit and then its parent commit, whatever. Does this kind of help you guys understand? And then checking out to a certain branch or a certain commit, all it's doing is just bringing that version when you committed it into your current working directory, into your current folder. All right. Anyone have any questions before we move on? Okay, cool. Yeah. So,
Oh, hold on, I have a question.
yeah, of course.
So how do you keep track of the hierarchy of it? Like, do you have to manually keep track of it, or Git is gonna do it for you?
So there's some extensions, like I think in VS Code, there's a Git graph. Oh, I don't know what it says. Huh. Well, for some reason this is not working, but usually it does. It's hard to keep it visual, so that's why you're kind of going to use this git log, right? Because it's just going to tell you what each one's parents are. But the thing is that you're probably not going to have too many branches on your own computer. It'll be other people that have branches on their computers. And what you just try to do is always try to keep up with main, because main is like kind of a compilation of everybody's work. So you're always just trying to keep up with main. But yeah, so like if I'm on test will just show me all my previous ancestors. And then if I do git branch, it'll show me all the branches that I have. So if I do git branch, or sorry, git checkout main, then we do another git log, then main now just shows me itself and its parent and their parents, whatever. And these logs can get like thousands of commits long. And that's kind of how you'd follow along. And that's why you need good commit messages, just so you know what each one does. Does that make sense?
Yeah, thanks.
Okay. So yeah, like I was saying, git branch, it shows you a list of your branches and highlights which one you're on. Git branch -d branch name would just delete a branch. But you can't delete one that you're currently viewing, or if there's like unmerged changes or unpushed commits, like you have changes in your directory that you haven't pushed, or sorry, you haven't, we'll get into this more. Basically, if there's some things that you haven't done, git branch -d will show you an error. So if you really want to force delete your branch, you can do git branch -d -D branch name. And this pretty much just overrides any errors that are given to you in the process. So you should probably be careful when you delete a branch, because it might be just hard to find where you were at before. Okay, yeah. So now I want you guys to go to github.com or like if you haven't before, make a GitHub. I'll give you guys like a couple minutes to just go to the website and make an account. Just because, yeah, it's gonna be a useful tool. You know, while we're at it, we can go ahead and just take like a 5-minute break or something like that. You know, I'll just do like 7 minutes. And yeah, if you can just during the break, just try to finish your setting up your GitHub account. And then we can move on to kind of a remote repository and getting work on there. All right, everyone, it's been the 7 minutes that I was giving you. So hopefully everybody was able to get a GitHub account going. Can I just get some like thumbs up or confirmations that you guys were able to do this? Okay, sweet. So GitHub is basically just a remote repository. So it's really similar to a local one. And it's going to be connected to your local one, but it's just you can see everybody else can see your code. So I want everybody, if you can, to try to follow along with this. So just create a new repository. You know what, I can just go on my GitHub as well. Yeah. Okay, yeah, so I'm on my home page. And can you guys still see my screen? Okay, cool. So yeah, if you click this new repository, and I'll just make another one called practice, right? So you can just make a practice repository, and I'm just going to say create repository. So that's all you need to do so far. So now we're here, and we've created a repository, and it's going to tell you to create a new repository, like a new local repository, or you can push from an existing repository onto this remote one, right? So I typically like to do this route, just make a repository myself. So I want everybody to kind of do what we've been doing, and just make a folder on your desktop, right? Uh, you know, some project folder, and we'll just call it Hello World. So I'm gonna go to my desktop. Okay, yeah, so just make some folder that you can use, and then have a file in it called hello world.py. And then you're just going to be printing hello world in that file. And then when people are done just doing this step, just start giving me some thumbs up in the chat. And then yeah, just try to get your, your hello world to actually run.
Hey Ryan, quick question. We just need
Yeah.
to create a hello world file. That's it.
Yeah, as long as so I'd create a folder, right? So you just have like I have my hello world folder on my desktop, if you can see in the bottom right,
Okay.
and then just have a hello world.py file in it, and then you can kind of run hello world from, or you can put your code inside of the hello world.py file.
Okay.
Okay, yeah, so I actually got a question in the chat just asking, can you explain your if statement? Why not just put main? I'm not exactly sure, honestly. I haven't ever looked into it. It's just kind of the convention. I could look it up right now. Um, Basically, I guess it's just checking if the script is running directly, but honestly, I'm not going to get too in depth with it. It's just a common thing that you do. I think you can also just, instead of having the main method, if I wanted, I could just have, or, oops, I'll say I never do this, so I'm not sure. If I wanted, I could just do print hello world outside of it, and then just get rid of all this. I forget if this would work or not. Okay, yeah, so this works too. I think it's just if you have a main method, you need to do the if name equals main thing. But yeah, I honestly never looked into it. Okay, so pretty much what we're gonna do is I want you to just follow along. Make a new empty local Git repository. So that's what Git init does. And then you can, once you do that, if you're in VS Code, you'll see this like green U, or the text turns green. And then we can add it by doing git add dot, and then we commit it by doing git commit, and then we can just, it's not that important. So we can just say first commit for hello world, right? Okay, so now we've committed this. Perfect. Once you've done these steps, you can copy paste these three in, and I will explain what this does, but I'll show you kind of what happens first. So right now I'm on my practice repository on my GitHub, and it's completely empty. There's nothing in it. And so it's just saying push an existing repository from the command line in order to populate this repository. So we are just going to copy these 3 lines because we've already made a repository. We've already committed once, and we can just copy paste these in. And now it's connected to our GitHub, and we've pushed to our GitHub. So pretty much if I go like back to my GitHub and I reload the page, now we'll see my GitHub is populated and it has a file inside of this repository called hello world.py. And then we see its commit messages right here. I did it 1 minute ago. We have 1 commit. Okay. Can I get some thumbs up when everybody's followed along? Okay, so I'm gonna go ahead and keep explaining it. If you need me to slow down, don't hesitate. You can just do like a thumbs down or something like that if you want. Okay, yeah, so pretty much, unfortunately, I already did it. But someone asked me just to explain where you do the copy paste. I think I might have it in here. Okay, yeah, so if you see step 3 on my screen right now, oh wait, no. Oh yeah. So if you see in your GitHub repository, if you don't have anything in it, towards the bottom of the repository, there will be these 3 dots, and then it says or push an existing repository from the command line. And then it says git remote add origin, and then HTTPS, whatever. You're gonna copy these 3. Oh yeah, so I've got a couple questions in the chat just asking like there's some people are getting some things that say author unknown. Basically, I'm gonna put these things in the chat. If you run these 2 things and fill it in with your username or with your actual stuff, basically Git just wants to know your name and your email to know who the author of it was, if that makes sense. So then you can kind of keep track of who's working on what. So I'm gonna put this in here. If you just copy paste these 2 things, and then uh fill it in with your actual information, then it'll configure your Git account to have your name and your email. So I'm just going to go through these steps one more time. So pretty much you create a new repository on your GitHub, and it brings up this screen right here. If you guys can see my mouse, and then you just fill in your repository name, whatever you want to name it, doesn't matter. And then you press the green button in the bottom right that says create repository. Then you can just go ahead and make some folder. I called this one test in this example, and then a file called whatever you want really, but in this example, I did hello world.py, and it just has some code in it, right? After that, I just do the things that we need in order to commit our code to our repository. So I make a new repository by running git init in the terminal. I add it by doing git add dot, and then I commit it by doing git commit and then -m and then our message for the commit. After that, this is where I'll kind of go through and explain what's really happening. So the git remote add origin and then this link right here is basically just saying we want to link our remote repository, so that's stored on our computer, with the GitHub repository or like the remote repository. So it's just we've created a link, and that link is called origin. So just keep in mind, origin means my remote repository. Origin means my remote repository. Now, if I do git branch -m main, all that it's doing is just turning your current branch into main, which it probably already was because this is a new file or this is a new repository, but that's all that git branch -m main does. And then git push -u origin main. This is like the big command when it comes to remote repositories. So pretty much I'm gonna do a bit of an example here, but pretty much git push the -u sets the default branch that you push to, which we'll talk about more, as origin/main, which basically just means on my GitHub account, we see that there's this tab right here where you can switch between branches, right? It's just saying that I'm pushing to the remote repository's main branch. And so that's why it has hello world.py. Okay. So you guys are pretty much just going to focus on, or I guess that's not necessarily true, but yeah, the push is what gets it onto the remote repository. So actually doing commits doesn't do that. So like if I'm back on my hello world file and I want to print another one that says hello everyone, right? Then I gotta add these changes. Okay, so I've just committed my file. All this commit does is just commit it to my local repository. Now, if I wanted to get it onto the GitHub, as if we look right now, I'll reload the page. It still only has knowledge of our first commit. Okay. So it doesn't have knowledge of any other commit. So just this one commit. If you want to get it, your commits that you've done, you can do multiple. So I'll do another one. Right. I'm going to git add. And you want to push to a certain branch. Oh, sorry, I just got something in the chat. So copy and paste from git command. Yeah, so basically you're just going to copy and paste these 3 lines after you've committed in your actual Git repository. So just see these 3 lines on the GitHub, and this is where you're going to commit from. Or this is where you're going to copy paste from, my bad. And you're just going to do that into your terminal.
Sorry, Ryan. So after copy and paste that, and I got a command git branch /m and git push /u origin main, right? After doing that, 5 and 6.
Well, yeah. So do you see like the image right here?
Oh, I'm just going to have to do that, and that's it.
Yeah, you literally just copy these from the GitHub. Like on your GitHub page, it should have these 3 at the bottom, like the
Yeah.
GitHub repository. You literally just copy that and then just put it into your terminal, your VS Code terminal.
Oh, okay. And then I'm going to go back to my main page or something. Or
Sorry, what do you mean by the main page?
where can I check the stuff that is linked?
Okay,
On
yeah. So if you just go to the back to the repository that you made on GitHub, if you just reload it, then it should pop up with your hello world.py file.
Oh, okay. Oh, okay. Yeah, I see. Thank you.
Mhm. Okay. Sorry, 1 second. Okay, so if you haven't gotten Git, if you haven't gotten, or I'm getting one that says inputting Git in it gives me an error. The term Git is not recognized as the name, whatever, blah, blah, blah. Have you run Git space version? Because if you do that and it doesn't, um, okay. Um, Here, did you guys get so are all you guys Windows users? Okay, so if you got if you're having errors, so is everybody on Windows having errors? Okay. You know what? I might honestly have to just debug the specific cases after, just because there's a few that are kind of specific, so I'm not exactly sure.
I think that if like you're missing Git or something, you have to add it to your virtual environment.
Mhm.
So you have to search up environment, it says edit the system environment variables. And then you click environment variables, you go to path, and then you have to add the Git to your path, I'm pretty sure. That's some people, because it depends where they download the installation.
Yeah, no, that's definitely a good point. So it might be some extra steps that you have to take. Basically, completely forgot to mention this in the installation. Pretty much your uh when you install Git, it should have an option that says add, or it might have been VS Code actually. I don't know. It might have given you an option that says add Git to path. I should have let you guys know that that is what you want to fill in, but I'm not exactly sure that that's what it was. But yeah, sorry for the specific cases. I might just have to like help you guys after, um, if we even have time. We'll see. Okay. So I'm sorry about that. But yeah, so where was I again? Okay, yeah, so the git push dash u, the origin main, basically just sets our default branch that we're pushing to as origin slash main. And that just means the main branch on my remote repository. So origin slash main means the main branch on my remote repository. All right. So then, like I was saying, origin just uh origin just references your remote repository, which you did in step 4 by doing the git remote add and then or git remote add origin and the GitHub link. So getting kind of more into what pushing does. As you guys saw, I have made a couple of commits. I guess I just did the exact same thing on accident, but it's okay. So if I look at my git log, yeah. So we see now, I've done 2 commits, right? And basically our main branch, which is on the local, is at this third, or sorry, I've done 3 commits and it's at this third commit, right? However, we see origin slash main is kind of 2 commits behind origin main. So what you do is you say git push origin main. And as long as you get no errors, it should update your origin main to kind of be where your actual main is at. So if you run git log, now we see origin main is here. And if I go back to my GitHub and I reload it and I look in my hello world.py, now we have the current change. So pushing is basically just how you get your code or get your remote branch or your remote repository updated. The branches in your remote repository updated. And now if I want to make a new branch, let's say, right? Let's say I do git checkout dash B, and then I'll just call it new. So now I'm on a new branch. If I add another statement, let's just say fourth, right? And then I do get my git add. I do my git commit. We committed it, it's fine. Our normal branch or our repository is the same. There's no other branches right here. So then, once again, in order to update, you should do git push origin, but instead this time you go instead of going git push origin main, you'd say git push origin new, which is the name of your branch right now. So pretty much it just when you create a new branch, it just assumes that your pushing to the same repository, I guess is the right way of saying it. So now we made a new branch on our actual remote repository because we did git push origin new. So if we look, new had a recent push 17 seconds ago, and this one has our most up-to-date code, and origin main is left behind. Were you guys able to follow along at least some with this? I know I'm going kind of quick right now. Okay, so the command I made to make a new branch, are you saying on my local repository or on the remote repository? Okay, yeah, so pretty much how you do it is you say, so I look at my branches right here, and I want to make another branch, right? So I'm going to do another branch. This is just on my local repository. This is not doing anything to the remote repository. Just think of pushing as it's going to the remote repository. Everything else is kind of just, it's all on our local repository. So I'm going to say newer. So I checked out a new branch newer, and then I want to make another change that says print fifth. Okay, so just made another change, print fifth, while I'm on my newer branch. I do my add, I do my commit. And then in order to get it onto the remote repository, I do git push origin and then the name of the branch that you're currently on. So if I want to, like, since I'm on newer, then I'll do git push origin newer. So we look here. Now we see that it's created a new branch on github.com/RyanCarney/practice.git. And then I go back to my GitHub, reload it, and then we say newer has had a push 12 seconds ago. So then now I can go to this tab right here, which currently says main because we're looking at the main branch, and I can go to the newer one. And now we see that has my most recent commit on the most recent branch. Okay. Is everybody good so far? Any questions?
One question.
Yeah.
Is so like git push, it's basically like almost like uploading whatever you changed into your repository on GitHub.
Yep. So just think about it like it's kind of by the branch, right? So if I make 5 commits on my one branch on my local repository, it's almost like if you do a git push to, like, if I'm on main, right, and I make 5 changes on main on my local repository, if I do git push origin main, it's basically just pushing those 5 changes up to my branch on the remote repository. Does that make sense?
I think so. So like when you push those changes,
Mhm.
it goes to it doesn't go to the parent one that like all the branches came from, or if that makes sense. I don't know.
No. It's almost like 2 separate lines. Oh shoot, I
Like the
need to go
animation you had, basically, like where it was.
yeah, I need to
So
be on like another. I need to get my iPad out or something. Sorry, what were we gonna ask?
so like I took a peek at the task, but like you'd have like different people working on each branch, correct? And then at the end you'd merge them. Is that
Yeah, so basically how you can do it, just because I don't think we're gonna have time and it's very complicated getting into merges, like actual a git merge. What you can also do is just, and this is not like an industry standard or anything, it's just purely out of like getting it done. if you just take a peek at other people's branches on the remote repository and you just copy paste it into your own, then that also just works that way because you're kind of just sharing your code. So you're using that part of Git, but you're not using, the actual merging because for people that have used Git, you understand how complicated like merge conflicts can get, and I just don't want to get into all that right now. So yeah, pretty much.
Gotcha.
But you're right about the branches. Like the idea would be that, one person would make a repository, they invite other people onto the repository, and then pretty much everybody makes their own branch, and then you push to your own branch on the remote. So like let's say there's a team of 3 and it's me, Jalen, and Aniket that we're a team of 3, then I'll just make a branch called Ryan. Jalen makes a branch called Jalen. Aniket makes a branch called Aniket. And then we all just push to our own branches, right? So then the main is almost untouched. And then we just kind of copy paste from each other, right? And then, so like, I'll see your code uploaded on your branch. I'll go into yours, copy paste your file into my local repository. And then at the end, someone can combine all 3, so all 3 files, and then just push it to origin main, and that's like the final product.
I see what you mean.
Mhm.
Thank you.
So they can't each push their own branch to main?
So I mean you
Or I mean
can't.
the file. Sorry.
So I guess yeah, you could each push a file to main. That would be fine. I think I want you guys to do your own branches just to kind of get in the practice of it. Because we're not doing any merging, so it shouldn't be too bad. But you definitely could do that, yeah.
Okay, thank you.
Any other questions? So I don't think it's just the admin is the only one that can push to main. I think I didn't really push to main much in my group projects, if I ever did. But I think anyone can push to main if they want to. I might be wrong though. I forget. I'll test it out and then I'll figure it out. Okay, anyone else not feel comfortable about like getting from your local repository to a remote repository? Okay, cool. So if no one else has any problems, I know that there are a few of you that have had setup problems, and so we'll do the best we can in making breakout rooms. But basically next up we have an activity. And I don't think we're gonna have enough time to get it fully done, but yeah. So pretty much I want you guys to develop a project in a team environment. So then we're gonna be doing it in Python, and ideally we're gonna be split up into teams of 3, and each person is gonna build one class in Python. And these classes are going to be interacting, so, and I'll get more into it. And these slides will also be here, so you guys can kind of follow it along. But I want you guys to make one person does the employee class on one file, another person does the car class on another file, and then the third person does the dealership class on a third file. Okay. And then yeah, just don't play with each other's files. It's just a lot easier. And then we have a submission, I like a Google form just to put your GitHub link. I still want you guys to do this. It doesn't have to be finished code, but I kind of just want to make sure that everybody can at least get something onto their GitHub, like I said, it's just for our feedback. So I would like if, even if it's not finished code, just to submit some GitHub link so I can just take a look at it. But yeah, so we'll get into it. So pretty much, I'm just going to go over this really quickly because you guys can kind of read it and ask questions if you need. But there's going to be a dealership, and then that dealership is going to have, if you guys remember, it's going to have like fields or like instance variables. So each dealership's gonna have a staff, which is just a list, a Python list of employee objects. And then it's gonna have an inventory, which is just a Python list of car objects. It's gonna have some revenue. So it's just gonna be a number that is the total amount of money made from selling cars. And then we're gonna have some functions. Yeah, get revenue, which just returns the revenue of the dealership, sell car, add car, get cars, add employee, things like that. I hope this isn't too hard to understand, but I just want to go quick through them just so you guys get more time to actually get a crack at it. So yeah, next up, it's just going to be an employee. So its instance variables or fields are going to be the number of cars the employee has sold, the revenue it's that employee has generated, it's their position, which is like either a salesman or a manager, and then their name. And then just some methods or functions so you can like set their position, get their position, increase the number of cars they sold, things like that. Yeah, like I said, I think you guys can figure this out. And then a car object, and then that one is basically it has a Boolean, which just says if it's true, if it's used or not. So used will just be true or false. And then miles, which is number of the miles on the car, completely arbitrary, just wanted to have it. And then the model, and you can either do like a number or some sort of name for the car, but you're making a completely fake dealership, so you can name them however you want. And then a few functions for that car as well. So yeah, so I want you guys all to take a look at the slides. I'll link them again in the chat if you want to just take a closer look at what you need. But when we go into breakout rooms, each person should take one of these classes. And then to get started, I want one person in your group to make a repository, and then the other groups should make a clone of this repository pretty much, which just takes the URL of the repository, and then you run git clone the URL, and then that just basically brings that project onto your computer and you can start working on it. And when you push or things like that, it's already automatically connected to that remote repository. That makes sense. And then if you want to make a new branch, which you should, before you start putting your work on it, you can just do git checkout and then -b with your name. Okay, does anyone have any questions before we get started in the breakout rooms? Okay, if not, I'm gonna go ahead and stop recording, or at least pause the recording.